How are you doing? I hope your weekend was great. Yeah. Today we are come to learn something special or interesting about a line. But before we start, let's do some recap. Can you please give me some examples of a straight line? Beautiful. Wonderful. Sure. All your answers are correct. And I love the responses that you gave to me. So let me draw your responses on the board. The vertical, the horizontal, and the what? And the slant line. Thanks for your responses, and I really appreciate it. But today, let's look at something special about the slant line. With this slant line, we have something called gradient. You can find the gradient of this slant line. And what is a gradient? Gradient is all about how gentle or steep a line is. So today, our topic is the equation of what? A straight line. When you talk about the equation of a straight line, it's all about what? A mathematical concept that deals with what? The relationship between the x and y coordinates of a point on the line. That's what the meaning of the equation of a straight line. So we can find the equation of a straight line in various forms. One is the what? The 2-point form, a point and then the intercept, the gradient intercept form, and then the general or the standard form. Alright, so today's lesson, I just want you to cooperate with me so that we can have a very interesting and intriguing lesson.
Let us start with the 2-point form. So we want to find the equation of a line when 2 points are given. And we are going to make use of the Cartesian plane. And so let's say we have a Cartesian plane and there is what? A diagonal line on it. And we are supposed to find what? The gradient and the equation of a line from the 2 points given. How are we going to find that? Let us do that. Okay. So this is our Cartesian plane. This is the y-axis and this is the x-axis. Now let's say we have these 2 points over here. This is point 1, so let's say this is P1. And then this is point 2. Let's say this is P2. So these 2 points have been given. We are going to trace them to what? To the x-axis and to the y-axis. So each point has a coordinate, x and y. So let's say this is x1, y1, and then this is x2, y2. Now when we trace this, it means that at this point, a change in s has occurred. It means that at first the point was here, it has moved to this side. And then from y also, a change has occurred. So this will be change in y, and this is change in x. But how do we find the change in terms of what? Numbers. We do that by subtracting the second s value, by subtracting the first s value from the second s value, by subtracting the first s value from the second s value. And so we are going to get x2 minus x1. Good. Now, we also want to talk about the change that has occurred in the what? In the y-axis. And so we subtract the first y value from the second y value, which is good. Now from Pythagoras' theorem, we all know that when we are given the opposite and the adjacent, so we are going to use what? when we are given opposite and adjacent, what are we going to use? Yes. Good. We are going to use tan. And so, supposing our angle is here, let's say theta, we are going to use what? Tan to find what? The hypotenuse. In this case, the hypotenuse becomes what? Our gradient. Let us denote it with the letter M. Okay. So we say from Pythagoras, tan theta is equal to opposite over adjacent. Very good. So we are saying that tan theta is going to help us to get what? The gradient, which we are denoting by M. So we will say that gradient, which is M, is equal to. Now when we look at the opposite side, we have change in Y. And then when we look at the adjacent side, we have change in X. Good. So now, our change in Y is equal to what? Very good. Y2 minus Y1. And then, our change in X is equal to, very good. X2 minus X1. Right. So, if you want to find the gradient of a given line, this is the formula that you are going to use. So the 2 points that you are given, we find x1, x2, y1, y2, and then you put them into this particular equation, and that will give you what? Your gradient. So you're going to continue to find the equation of a straight line when the gradient is known.
Okay, so right now that we have our gradients, we can now take the gradient and 1 point from the point given. See, we are taking the point P, which is our x1, y1. So now we can say that our equation is now y minus y1, which is equal to the gradient multiplying x minus x1. So this is our equation of a straight line. When we are given the 2 points, you take 1 point and then the gradient, then you substitute the values and then you find the equation. So let's take an example. Assuming we have been given this line to find the equation of this line. Now we first find the gradient, and we know our gradient to be the change in y over change in x. So from this diagram, our change in y is y2 minus y1 all over x2 minus x1. So from here, our x1 is this one, our y1 is this, our x2 is this, our y2 is this. So our y2, which is 6 minus 3, equal to our x2, which is 5 minus 2, giving us 3 over 3, which is equal to 1. Now that we have our gradient to be 1, we take any point. So let's take point B, which is 5 and then 6. So remember, our equation here is y minus y1, which is equal to m, which is the gradient, multiplying x minus x1. So here our y minus 6, which is equal to our gradient, which is 1, x minus x1, which is 5. So y minus 6, which is equal to x minus 5. Y is equal to x minus 5 plus 6. So y is equal to x plus 1. So this is our equation of this line. We can also say that this is also equal to y minus x minus 1 is equal to 0.
We can also find the equation of a line when a point and a gradient is given. So our subtopic is a point and a gradient for Okay, so let's try this question. Find the equation of a line with gradient 3 passing through the point 4, 9. Okay. So the gradient is 3 and the point is 4, 9. So we can use our formula to find the gradient, the equation of a line. Y minus y1 equal to mx minus x1. So our y1 is 9 and our gradient is 3. X and our x1 is 4. So y minus 9, 3 times x is 3x minus 4 times 3 is minus 4. So our 3x minus 12x plus 9. So 3x minus 3. Y is equal to 3x minus 3 is our final answer.
Now let's continue with the lesson. Now we have learned that the equation of a straight line can be found in different forms. And one of the forms is the slope-intercept form. Which is given by y is equal to mx plus c, where c is the intercept on y, m is the gradient, x, y is a point from the Cartesian plane. So let's see how this expression can be deduced. So let's say we have the x, y plane or the Cartesian plane as we have on the board. Now, you draw a line to cut the y-axis to a certain distance. Then, you draw a line again from point P, perpendicular to the x-axis. Which is x. Then you extend it corresponding y-axis here. So, the P being the point will have coordinates x and y, and then C being the intercept on y, and then we know that on the y-axis x is equal to 0. So meaning that C will have coordinates 0, C. So now this line is the slope. So we just have to indicate on it that it's a slope, which is equal to m. Alright, so now since the 2 points, which is P and C, all lie on the same line, then we can confidently find the gradient of this particular line. And then we have already deduced the formula for finding the gradient of a line, which is given by the change in y over the change in x. Now when we look at the diagram we have on the board, the 2 points, then we can say that, or let's say this would be my y2, and then this would be my x2, and then this would be my y1, and then this would be my x1. Then we just do direct substitution. So I will maintain my m. So y2, with the point that we have over here, my y2 here will be y. And then my y1 will be c. And then from that same 2 points, my x2 is x. And then my x1 is 0. Then we simplify this formula or expression. Then that gives us mx is equal to y minus c. Now can you make y the subject from this expression? Yes, good. Now when you make y the subject here, we are having y is equal to mx plus c. So this is the slope intercept form of which we can also use to find the equation of a straight line. Now let's try this example. Find the equation of a line with gradient 4 passing through the point 1, 10. Now you may ask that said there's no value of c or there's no c value in the expression. Good, there's no c value, but since we are given the point which is x and y, 1 and 10, and then the gradient in the expression, you can use those values and substitute them into the formula to find the value of the constant c. Now when you are done finding the constant c, then you substitute it back with the gradient given in the expression, then you have your equation of that particular line. Looking at this expression, we have our gradient which is m is equal to 4, x is equal to 1, y is equal to 10. So putting them into the formula, we have putting them into the formula, we have 10 is equal to 4 multiplied by y plus c. So when you make the c the subject here, we have c is equal to 10 minus 4. And then our final answer for the c is what? Is 6. Then you go and substitute the value of c into the formula, then you have your equation of that particular line. That gives us y is equal to 4x plus 6. So this will be our equation of the line. Now we have already discussed that we have other forms for finding the equation of a straight line. We have a standard or a general form of which we can use to find the equation of a straight line, which is given by ax plus by plus c is equal to 0, where a, b, and c are constant.
Okay, today we learned much about equations of a line. We started by looking at the gradients of a line using the x and y coordinates. Then we go ahead by looking at various forms of finding the equation of a line. We look at the 2-point form where 2 points are given on the line. Then we use the 2 point to find the gradient. Then from there we proceed to use one of the points and the gradient to find the equation of the line. Then we also look at a point and a gradient form, where a gradient is given and a point is also given. Then you use it to find the equation of the line. Then thirdly, we looked at the slope intercept form. We also spoke about the standard form of finding the equation of a line, which we'll go more into it in our next meeting. In our next meeting, we'll talk about the equation of the parallel line and then the perpendicular line. But before we go, let us take this exercise. Will be submitted in the next 15 minutes.